Welcome, everybody. Glad to have the three of you here live at the moment. So two main purposes. We want to see if there are questions on lesson 1.8. We also, of course, want to begin our chapter 1 review. So I'm going to open it up with questions that people would have on lesson 1.8. Remember, if you can use the chat button up in the top left corner, the little blue rectangle with horizontal lines. If you click on that, it'll open the chat window on the right, and you can send me a question that way. Or you can call, send a text to 262-510-2046. Is that right? All of a sudden I can't remember. I'm sorry, 262-510-2046. I believe that's correct. Or email, or just speak up. So questions on 1.8. I got one by text. Let's see what I got here. 29, evidently that must be on, 29 must be on lesson 1.8. All right, number 29, we'll do that one first. Okay? Thanks for asking. So I'm going to share, first of all. Let's get this sharing thing going. And then I'm going to just expand my screen a little bit so we can see a little bit more. Okay. All right, now let's go to number 29, or at least let's see if I have it. I do. Number 29. So 29 is asking what? And write the solution in interval notation. So there it is, x squared minus 1 squared times x plus 2 cubed is greater than or equal to 0. Well, it's nicely factored for us already, isn't it? So I got to just get this down. We got number 29. I think I just got another request. No, I'm not sure. We'll check on that later. So anyway, here we go. All right. We have x minus 1 times x minus 1 times x plus 2 times x plus 2 times x plus 2. And before we do the greater than or equal to that's in the problem right here, before we deal with that, let's find the crossing points, which, by the way, the book calls critical numbers. Kirsten? Is it looks like you're asking for number 51. Thanks, Kirsten. Okay, so I've got another request after this one. You want to look for the equal first. Those are where it crosses the x-axis, and the book calls those critical points. I did not verbally speak about that last time, and I'm sorry. I wasn't trying to goof you guys up. Anyway, so it's already factored. So where are the crossing points? Well, if you there's 5 factors. X minus 1 equals 0 would give you x equals 1. So we know that's a critical point, x equals 1. We also know that x equals negative 2 is a critical point. Okay, so let me just see what's going on here. Yeah. Now, I know something you don't know yet, but you will know soon, is that the fact that one of the factors occurs twice and one of them occurs 3 times. I'll just give you a little tip on the future. They call that in the future, you'll hear that called multiplicity. So this one has the answer x equals 1 with a multiplicity of 2. Why? Because it occurs twice. The answer x equals -2, and that has a multiplicity of 3. When you have an odd multiplicity, then you have a bouncer. And when you have an even, you have a crosser. So if you look here, I have the graph up. Sorry, just the other way around. When you have an even multiplicity, you have a bouncer. And when you have an odd one, like -2, you have a crosser. So you see how the graph crosses at -2, yeah, right behind here. And it's a crosser. That is, it crosses the x-axis, whereas not real important, but over here, x equals 1 is a multiplicity of 2, and we have what I call a bouncer. It just like bounces off the x-axis. Okay, so anyway, we're looking at the graph. So we have two critical points, 1 and -2. What the book recommends you do is simply do this. Set up, let's just take, let me write here. So we got a point. Let's just say this is at -2, and then we got another point at 1. We know those are crossing points, so just pick some points to the left of -2, like for example, -3. Plug in a -3. Well, let's quick do it. -3 minus 1 is -4. -4 squared is 16. Okay. Then plug in -3 again. -3 plus 2 is -1, and -1 cubed is -1. What's 16 times -1? -16. Is that greater than or equal to 0? No. So this is what? Let's just say below, because it comes out less than or equal to 0. Now let's pick a point in between. What's a nice point in between here? Between -2 and 1 with 0. That's an easy one to calculate with. 0 minus 1 is -1. -1 squared is 1. 0 plus 2 is 2. 2 cubed is 8. And that is 1 times 8 is obviously bigger than or equal to 0. So we're above here in the in-between part. And then let's pick a point over here. Yeah. I'm not sure who's calling me, but I think I'm gonna just avoid that right now. Sorry, you'll have to put up with the ring. Let's pick a number after 1, like let's say 2. What happens when you plug in a 2? 2 minus 1 is 1, squared is 1. 2 plus 2 is 4. 4 cubed is 64. And when you take 1 times 64, you certainly get a number above. So you can already see when that this curve is on or above the x-axis. And you can see it's everywhere past -2. Below, to the left of -2 is the only time. And sure enough, look at the graph over here. Isn't that true? When is this graph above? Well, after -2, it's above or on. It's on right here. It's on or above everything after -2. And so here is our interval notation. So here's the answer in algebra. And here's the answer as they ask in interval notation. So -2, it's on. So we're good. It's above or on. So forever, infinity, and anytime you use an infinity, you've got to use a rounded parenthesis because there's no endpoint there. So that was number 29. So I can't remember who asked about that, but that was my text message. I'm going to go to the second one now. I got a request for number 51, so I'm going to go there. Number 51. Okay, we'll just do this one. Let me make a slide. I got a request for 43. Okay. Thank you for the request. So here's 47. Now we'll insert and we're going to do 51. Okay. Okay, let's change colors. Yep, and I got a 41 request. All right, we'll see if we have time for all of those. Thank you. Appreciate the requests. Oh my, they're all coming in now. 35. Okay. We'll see. I'll try. All right, so let's do 51. So this, it says use a graphing utility to graph the equation. Use the graph to approximate the values of x that satisfy this. And the equation is y. All of a sudden, no writing. I don't quite know why. Let's try that again. Yeah, we got a little, let's see, problem here. Come on, pen, wake up. Well, while I'm waiting for my pen to wake up, I'm going to do this one in Desmos, okay? So one more time, what was it? Oh, part A says y is greater than or equal to 1. Okay, so anyway, we should be able to do Desmos whether my pen is active or not. So here we go. Desmos. Coming up. So first what I'm going to do is I'm going to put in, which is, let's see, we need, yeah, 2x squared, and then divided by, and in the denominator, x squared plus 4. Put that all in the x squared plus 4. There we go. So there's the fraction part. And then in part A, it says y is greater than or equal to 1. So I'm going to say y equals 1. In part A, the question is, when is the red curve greater than or equal to 1? You know, it says, yeah, it's, well, the critical points are these two right here, right? As you can tell, I'm pointing. -2 is one critical point. So where does it equal? At -2 and 2. When is it greater? When it's less than -2, this part out here, and when it's greater than +2. Okay? Now, part B says, what about 2? So this time, let's change this to 2. The answer is, when is the red curve, and here, let me go a little smaller so you can see what happens when we zoom out. Is the curve below or equal to 2? And isn't the answer always? Yep. So in that particular case, it looks like this curve, what, approaches 2. There are no crossing points that Desmos brings up. So part A, the answer would be what? When it's less than -2 or greater than 2. And part B, you would say, when is it 2? Always. So that's number 51. Now, let me come back and see if I have a pen. Well, I got a pen with a mouse, but all of a sudden I'm going to quick jostle my batteries. See if that does it, okay? Hang on just a second. So it looks like I'm just scribbling on the screen, huh? Let's see if jostling the batteries helps. Yeah, cool. Okay, so we did a little tech troubleshooting here. But anyway, that's really all I need to show you on 51. I'm going to go to the next person who asked for 43. And I'm going to make this bigger again. Okay, number 43. And see, we have the neighbor cutting grass. That's nice that that comes through here too. 3, solve the inequality and graph the solution on the number line. So here it is. 1 over x minus 3 is less than or equal to 9 over 4x plus 3. So I got to get, I mean, all our x's are in denominators. This is not good. So what we have to do is we've got to multiply through and get those denominators out of there. So what's the LCD? You see that in blue. X minus 3 multiplied by 4x plus 3. So on the left, what happens? The x minus 3's cancel, and you get 4x plus 3. And on the right, the 4x plus 3's cancel, and you get 9 times x minus 3. So let's just, I'm not sure what's in the box, so let's just come down. So here's what we got right here. Right? So all I did was multiply both sides by x minus 3 times 4x plus 3. So here's the problem. How do I know if x minus 3 and 4x plus 3, when multiplied on both sides, are negative or positive? And the answer is I don't. So we've got a case issue here, okay? And so, yeah, and there's a bunch of cases. So I don't know if I probably don't have time to go through the whole thing. But hopefully you saw how I got to here. 4x plus 3 is less than or equal to 9x minus 27. That's not very hard to solve. You can subtract 4x from both sides, and then you can add 27 to both sides, and you can solve for x. The problem is, let me just, I think what I'm going to do is just make a new slide, and let's talk about the cases here. Okay, so come on up, sweetheart. All right, so think about what we got here. What did we multiply by? We multiplied by x minus 3 times 4x plus 3. Here's what I mean by cases. Case 1, let's say x minus 3 is negative and x plus 3 is negative. So in case 1, let's say they're both negative. So that means if we solve the x minus 3 is less than 0, add 3 to both sides, that means we assumed this. And if 4x minus 3 is less than 0, that means 4x is less than negative 3 when you subtract, 3 from both sides, and then divide by 4. Okay, so now if you put these two together, these two, we got an and here. So when you put these two solutions together, what's in common between those? If we're less than 3, here, let me just show you. 0, let's say that's 3. Negative 3/4 would be about here. So if you're less than 3, it looks like this. And if you're less than 3/4, it looks like this. And what's in common between those two? Where's the overlap? Less than 3. So all of case 1 comes down to x is less than negative 3/4. So if that's the case, and we, by the way, what happens if you multiply by 2 negatives? If you multiply by 2 negatives, that's the same as multiplying by a positive, and you don't have to reverse the inequality sign. So This thing we did up here, if I can scroll back, and I don't seem to be able to. Oh, that's because I'm on a new slide. So that algebra I did earlier, that fits this case because we did not change the inequality sign. All right. So that's case one. Let me draw a line. You see how complex this gets. Case two, what? They're both positive. X minus 3 is greater than 0, and 4x plus 3 is greater than 0. This comes down to x is greater than 3, and this comes down to 4x is greater than negative 3, x is greater than negative 3/4. Now, without me drawing it out, can you tell what's in common between those? If you're greater than negative 3/4 and greater than 3, that comes down to x is greater than 3. So here's the assumption in case two. So that doesn't change. I mean, if you multiply, since they're both positive and you multiplied both sides by both of them, that did not change the inequality either. So case one and case two are both compatible with the algebra I showed you earlier. As you know, probably, see if I can, trying to find that extend the page thing, and I can't, it's behind. So I'm going to just make a new page. All right, case three. Yes, there are two more cases yet, guys. Wow, what a wonderful time for the lawnmower next door to go. Okay, case three. So this time, x, let's say the first one is negative, and the second one, which was 4x plus 3, let's say that's positive. So one's negative and the other is positive. And again, this is and. So in case 3, x is less than 3, and 4x plus 3. I'm sorry. Let me try that again. What I want to do is solve this. So once again, I would subtract 3 from both sides, and then I would divide both sides by 4. Okay, now the question is, what's compatible between these? And it's greater than negative 3/4. Well, that's a sandwich. That's when x is between negative 3/4 and 3. Okay, so here's the case 3 result, and here we have to what? Change. Why? Because we multiplied by a positive and a negative, and a positive times a negative is a negative, so we would have had to, or I should say reverse. And guess what? We're still not done. A case 4. In case 4, what did I do up on case 3? I said the first one was negative and the second one was positive, so let's reverse that. Now, the first one is positive, and the second one is negative. That means x is greater than 3 and 4x is less than negative 3, x is less than negative 3/4. All right, look at this one. X is greater than 3 and at the same time it's less than negative 3/4. This one is impossible. X cannot be bigger than 3 and at the same time be less than 4. So good news. There is no case 4. So, so basically we have 3 cases to work out. And now, if I go to the original problem, as soon as it comes up, Yeah, this algebra I was doing down here. Okay, this algebra is fine for case 1. And for case 2. But I would have to completely redo this. Was in case 3. Okay. And let's get rid of this stuff down here. That's from another discussion. So, I mean, this problem is long. It's actually got to be carried out in 3 parts. And we're still not done. In 2, we came up with this answer, right? Right here. But you've got to then, we've got to, what do you call that? We've got to reconcile with the assumption in each of the first 2 cases. So this is 3 pretty long case problems that all have to be finished, and probably another half hour. So I'm going to call it quits there on that one, and 41 is so similar. I'm going to pass by that one. Let's see. Let me take a little bit of time, and we'll do 35. Okay, that was also requested. So for that one, we'll slide. Okay, insert slide. Come on, there we go. We'll change to blue. Okay, 35. So we've got 1 over x minus x greater than 0. Okay. Again, solve the inequality and graph the answer. All right. We still have, even though 1x is not in the denominator, 1 still is. We've got to get rid of this guy right here. So we still want to what? Multiply both sides by x. So if I change to black here, we want to take both sides and multiply by x. So on the left side, that'll give you minus x squared. And on the right side, it'll still be a 0. Okay, now the problem is, we don't know. I mean, let's call this case 1. This is case 1. And in case 1, we're going to assume that x is positive. And so I did not change the inequality. We're going to have to do a case 2 where x is negative, right? Yeah. So let's solve case 1. So we add x squared to both sides. And then we take the square root. Let's see, it's less than positive 1, and it's greater than negative 1. So in other words, x, in that case, let me think about this. So in that case, the answer is x is between and 1. And I have to make that, I have to reconcile that with the assumption. X is greater than 0. So there goes the negatives. It's got to be greater than 0. So really what we came up with is this. 0 and 1. So here's the case. So here, let me just write it this way. So inequality answer. So that's the case 1 solution. We still haven't touched case 2. So let's see if I have enough room here. So probably not, but we'll try. Whoa, what happened? Okay, we seem to be somehow lost in Neverland here with this. So case 2. Wow. Sorry, I'm having a little trouble managing. I guess I'm going to have to make another slide here. Case, I'm having trouble managing the software here right now. Okay, case 2. For number 35. Got the problem gone, so let me quick regenerate it. 1 over x minus x is greater than 0. This time, in case 2, we're going to say x is 0. When we multiply through by x, we're going to get 1 minus x squared, and I have to reverse this. Why? Because I just multiplied by a negative. All right. Okay. So the algebra looks the same. We add x squared to both sides, but you notice this time x squared is greater. And when we solve it, we get x is greater than positive 1 and x is less than negative 1. And that is impossible. X cannot be greater than 1 and at the same time I forgot to switch the sign. X is greater than 1, x is less than negative 1. X cannot be bigger than 1 and at the same time be less than 1. So case 2, while it's good we considered it, never came true. So now, if I can figure out how to get this back, there we go. We go back to where we were. And then how do I get... I'm trying to resize this, and I can't remember how to do it. Screen. View. Nope, that's not what I wanted. Sorry. What about Zoom? View. Well, at least that's better. Okay, so anyway, case 2 didn't work. So here's this thing that we found right down here, which was the final answer to case 1. There's my solution. And then finally you can graph it. Once you know all of that, all right, 0, 1, and everything is between those two. So using the book's type of graphing, you would go like this, putting 0 up to and including 1, and everything in between. And so the final solution for 35 would look like that. So this case, case 2, wound up contradicting itself, and we wound up losing. You can't, by the way, you can't ignore a case though. Now, I got to check. I got messages coming in. I got to find them. Hang on a minute. What are my messages? Five, 41, 43. Okay, well, we at least did a. No, we didn't do all of them. We didn't do 41, but 41 is a lot like 43. Okay, we better get to the review. And how did I lose that again? Here. Okay, I just can't remember how to do that. There's a, auto hide. There we go. We got her. And then to view page width. Where is that page width? Sorry, guys. There we go. All right, we're back. Well, I'm going to have to leave that for the 1.8 questions. Now, let's at least get a start on the chapter review. Okay? So we've got the 1.8, but I'm going to first go back. The dog is crying. Wonderful. Everything happening all at once here. Hang on just a sec. I got to get the dog moved into a different location. Yeah, I can't work with you right now, buddy. Dog is leaving. All right. So anyway, earlier in the chapter, I don't know what you want to go through, but let's just go through some sample problems. Okay. So back on lesson 1.3. Yeah. Well. Okay. So this is a reminder that sometimes we had to use standard equations like interest equals principal times rate. We also had to use what? Distance equals rate times time. We did a lot of those multiplication. Led to mixture problems. So I don't know. Do I have a mixture problem here? Let's see. So here's a 1-6 problem. By the way, I would love it if you guys would ask questions. We've done the 1-8 questions. It'd probably be better if I just responded now to you guys. How are we doing here? We got about 15 minutes left. Just for the moment, get off of in 1-8. And what other issues in the chapter would you like to talk about? Instead of me just rambling and looking randomly at other problems. I've got a ton of them up here, but it'd be better if I responded to your questions. So interesting problems here with the pen, the screen, the dog, the lawnmower. But what other parts of chapter 1 would you like me to start, re-explaining? I don't want to spend too much time on 1.8 because that's only 1 out of 8 lessons, and we only have 1 more day to go through questions. So I'm relying on you guys again. We have Brandon in here, Damon, Geneva, Kirsten, Matthew. Wow, only 5 people. Anyway, with those 5 of you have chapter 1 things.
Go ahead.
I asked about the
completing the square.
yeah, the square thing.
Yeah, that's right. This would be a good time for that, Matt. Thank you for reminding me. Okay, so somebody brought up that we need a little bit fuzzy on completing a square. So what I'll do, I think this is really worthy. So I'm going to make a slide here, and I'm going to make up a problem. You solve this by completing the square. By the way, you had one of those on your quiz, right? Remember that?
Yep.
So let me just say, solve by completing, sometimes put in quotation marks, the square. Sorry about the bad penmanship. All right, so let's pick a problem like, I don't know, x squared plus 6x equals 0. Let's say equals 2. Okay, x squared plus 6x equals 2. Solve by completing the square. So, the first thing you want to do is make a little space on the left. And then you want to do that, half of the b term is 6, half of that is 3. And you want to square that. That's 9, both sides. So we just completed the square on the left side. This is now a perfect square, and so we should be able to write it as a square. To do this, you take the square root of the x squared term. That becomes x right there. The square root of 9, the n term, and that becomes the 3 right there. And the sign from the middle is what goes in. Anyway, that squared equals 11. Now take both square roots. This is the nice thing about completing the square. You can proceed by taking both square roots. So x plus 3 equals plus square root of 11 and minus. So I'm just going to say plus or minus. All right, and now to solve for x is subtract 3 from both sides. So, and there we have our two solutions, solved by completing the square. That's the procedure. And let me review one that I kind of, you're having trouble hearing me, huh? Is that generally true? Are all of you having trouble hearing me?
I'm not.
Okay.
I can hear you.
So maybe Kirsten, maybe you need to turn your volume up a little bit on your own computer. I don't know, but I did turn mine up. I don't think that really affects it, but sorry, I'll try to keep my voice up. Now is let's just one more problem that I've warned you about that eventually is probably going to be on your final exam. And it also uses completing the square. So let me make a new slide. Tell you what I'm going to do. I'm going to do it a little differently. Let's go back. And I'm going to just clone this page. Save myself a little bit of time, and then I'm going to delete all this, and I'm going to say solve by completing the square, but this time do it on this equation. So I've been through this, and for those of you who know this already, you can ignore it, I guess, but this should result in the quadratic formula. So it's a good review because you got to do it with letters. It's a little bit, you got to be really sharp to do it with letters. We got one extra difficulty, but let's get rid of the C. So the first step is let's subtract C from both sides. So now we're sitting like that. Then we can't have this A here. So the next step I'm going to use is divide both sides by A, or multiply both sides by 1 over A. So that'll give me x squared. Cancel. Here, I got to divide by A, and I have to divide by A here. All right. Now we're set up because we have a 1 in front of the x squared. Now we can actually complete the square. So we have to take what? Half of this guy. The current coefficient of x is b over a. What's half of that? I'll just put it off on the side here. Wouldn't that be b over 2a? Yeah, it's like 1/2 times b over a, top times top, bottom times bottom, b over 2a. And then square that. Well, that's b squared over 4a squared. Add that to both sides. Now we have a perfect square trinomial over here. So the next step is to write it as 1 squared. Remember, square root of x squared, x. Last term, b squared over 4a squared is b over 2a. And then the sign comes from the middle, plus. Now, over here, we want to simplify this, and we don't currently have a common denominator. So in order to get a common denominator, can you see that I have to multiply top and bottom times 4a, so that this will become 4a squared, just like that one? That you have 4a squared as a common denominator, and you're going to have b squared minus 4AC. I put the plus first. You know, minus C times 4A is minus 4AC. Whoops. Okay, sorry, did a little dragging by accident there. All right, so now we're well on our way. This is the same old deal. Take both square roots. On this side, we just lose the square sign. And on this side, we have to take both. We know what the square root of the bottom is. What's the square root of 4a squared? That's 2a. We don't know what the square root of b squared minus 4ac is, so we're going to put that under a root sign. Okay, we're doing well. All we have to do is get rid of this. All we have to do is get rid of this this plus b over 2a, so we subtract that from both sides. You notice, if you write it that way, you see how we have a common denominator? So we can bring the numerators together. And sure enough, that's the quadratic formula. What I like about this problem is it shows, because you have to deal with letters, it shows that you really get the completing the square procedure. And since that's the question Matt asked me, I thought, all right, so we've done two problems. We did one, which was just what, a practical example problem. Here, let me just show you real briefly. We did this one where we just had a regular number problem and we solved it by completing the square. And we took it a step further and we did it in its most general case. When all you have is letter coefficients, you can do it that way too. This is the real pure one. Boy, if you can get this, you should have nailed how to do completing square with anything. So there we have that. Okay, I think Brandon, were you waiting with a question?
Yeah, I was just going to ask you symmetry. I remember I had a tough time with symmetry on the first exercise.
Okay. So, let's see.
Something quick.
We're talking about 1.1 now?
Yeah.
Okay, I'm going to quick try to find a problem so that we can use that to explain. So I'm heading back to 1.1. Yeah, so this would be like the questions on page 86.
Yeah.
So you want to pick an example, Brandon? Go ahead.
Sure. Maybe 33.
All right. So, let me just write it down. So what do we have for symmetry here? Let me just, here are the symmetry tests, Brandon.
Okay.
If we, let's say, plugged in a 1 for x, and then, okay, so you know what would happen. 1 minus 6 is negative 5. And so when you plug in a 1, the absolute value of negative 5, which is 5. So when you plug in a 1, 5 comes out the answer. Correct?
Right.
All right, let's plug in the same number with the opposite sign. What happens when you plug in a 1?
It'd be
minus. Go ahead.
Oh, it'd be negative 7.
And then the absolute value would be?
7.
So here's the idea. If this had symmetry, then I should have gotten the same answer for 1 that I got for negative 1, and you can see I clearly did not.
Right.
So now I know y-axis symmetry. Okay. What about Y? So I can't change the sign on Y either, because doesn't Y have to be in this problem? I mean, isn't that what absolute value says? It says, go ahead and you're not going to get a negative. Am I right? Y can never be negative here. So that tells me right off the bat there's no x-axis symmetry. So basically, this one doesn't have either x or y-axis symmetry. And what I did is I just showed you for finding symmetry. So how does one find y-axis symmetry? Plug in a value for x and plug in its negative. And if you get the same answer, you better try a different number, but try it at least twice. You know what I mean? If let's just say when we plugged in 1 and -1, we got the same answer. Oh, maybe try 2 and -2 then. And if they both work, that pretty much nails down that you've got y-axis symmetry. Conversely, if you can change the sign on y and you still have the same x, then you have x-axis symmetry. That's pretty much it.
Okay.
By the way, there actually is some symmetry on this one. Let's just say, I don't have room, so I'm just going to say this is 6 on the x-axis. This is what the graph looks like. So you can see, is there y-axis symmetry? No, because if this was the reflection point, I don't have mirror symmetry.
Right.
Does x-axis have symmetry? No, because then the same thing should be below. But actually, there is, even though there's no official symmetry, there is a folding point at x equals 6.
Okay.
So what you were supposed to do on that one is say, there is no x-axis, no y-axis symmetry. And so when I sketch it, yeah. At least those two types of symmetry didn't help me. So, and Brandon, to help you a little bit more, go to page 81 in your book. Have the 3 symmetry tests in that box.
Oh, okay.
I didn't go through the origin symmetry, but well, that, by the way, origin symmetry, if you change the sign on x and you get the same number y, but the opposite sign, oh, that's origin symmetry.
Oh, okay. Yeah,
So
I kind of remember that.
Yeah, so what you need to do is maybe look at a few more examples. They have some right there, but use that box on page 81.
Okay.
Questions? Somebody else waiting for a non-one-page question? Matt, I wanted to thank you for reminding me about the completing the square thing. Well, I guess we'll dig in and we'll do some more of this, obviously, tomorrow. Thanks. I appreciate your attendance. I think it's still low. I still only have 5. I believe so. Thank you. God bless you, you 5. Now we're down to 4, but appreciate it. I will see you tomorrow.
See you tomorrow.